So you know those bills that just hit you like a ton of bricks?
Oh, yeah, the unexpected ones.
Exactly. Those hidden costs that just sort of creep up. Now imagine that, but for your cloud data operations.
Hmm.
Even with like really cutting edge data engineering, one small slip.
And boom, a massive financial surprise can land on your desk.
Yeah, it's those invisible costs, the ones kind of lurking just out of sight in your cloud setup. They can cause the biggest headaches, right?
Absolutely. And it catches so many organizations off guard, even the ones who think they have mature data practices.
Right. So today we're doing a deep dive into this, well, surprisingly costly world of cloud data operations.
Mm-hmm.
Our mission is to really expose the most common mistakes, the ones that often end up being the most expensive.
And not just what they are, but why they're happening.
Exactly. Why they happen, and crucially, how you can avoid them. The goal here is to help you save money, build more robust systems.
Yeah, make things more efficient. And we've pulled together a lot of different perspectives for this.
Yeah.
Yeah, expert articles from places like Cloud Zero, Pipeline, to Insights, Informatica, big analyses from academic journals like IJFMR, plus insights from Oracle, Google Cloud, AWS.
Okay.
And maybe most interestingly, some really raw, sometimes painful, real-world stories from data pros on Reddit and Datanami.
Ah, the cautionary tales.
Those are the ones that stick with you. So hopefully you'll walk away with some really actionable stuff. Turn those potential oops moments.
Into aha moment.
Exactly. Aha moments of saving money.
Love it. Okay, let's dive right in then. The shocking reality when cloud costs just explode.
Yeah.
You mentioned Reddit. It sounds like it's full of these stories.
Oh, it really is. One that jumps out is this solo data engineer, right? Wasted like $4,000.
Wow.
Using PySpark on a single node Databricks cluster, but didn't set up a specific job cluster. Or even simpler, just forgetting a Redshift test cluster was running for a whole year.
For a year. Ouch.
Yeah.
That's a painful lesson in monitoring.
It really is. And it shows how easily these things can spiral. There was another one, $11,000 over just 6 months. For what?
Azure Kubernetes logging costs.
Yeah.
It was 4 times the price of the cluster itself.
4 times. Just for logs. How does logging get that expensive?
Well, it's often the sheer volume of data being logged, right?
Yeah.
And the retention settings. If you're logging everything and keeping it forever.
Yeah. Okay, that makes sense.
And it's not just logging. We saw another story, a $2,000 bill in just 48 hours.
Wow, fast.
Yeah, an Azure Data Factory pipeline just ran all weekend, no timeout configured.
Oh, no.
And it kept retrying a misconfigured API call, ended up costing $4,000 because of all the retries.
It's always the little configuration details, isn't it?
Seems like it. Or understanding the pricing model. Like someone got hit with a $5,000 bill because they misunderstood DynamoDB write pricing.
How does that work?
Well, they assumed a batch write of, say, 25 items counted as one write unit. Nope. It costs 25 write units.
Yeah.
A big difference at scale.
Ah, okay. That adds up quick. What else? Any really big numbers?
Oh, yeah. There was a Python PySpark job in Databricks. Someone left a while over.
True.
Loop running. Uh-oh.
Oh.
While. True. Sounds dangerous.
It was a $20,000 bill from that one mistake.
20,000. Oof.
And then there's Snowflake. We heard about costs heading towards $800,000 a month.
800,000 a month.
How data analysts building too many DBT models, that's the data build tool. Snowflake's auto-scaling just kept adding compute to handle it all, so the cost was kind of hidden until it got huge.
So wait, autoscaling's supposed to be good,
Right.
but it can actually hide these rising costs.
It absolutely can. It makes everything seem like it's running fine by just throwing more resources at it, but it can definitely mask underlying inefficiencies.
Okay, that's a tricky one.
We've also seen things like $450,000 in compute from N+1 Hadoop loops running over a weekend.
N+1 loops. Remind me what that is again.
Yeah, basically it's when your code runs a separate query or operation inside a loop. So if you loop 100 times, you might run 101 queries instead of maybe just 1 or 2 smarter ones. It explodes the compute needed.
Gotcha. Inefficient querying at scale.
Exactly. Or another big one, transferring 1.5 petabytes of data between GCP buckets in different regions with overwrite semantics. That resulted in a 6-figure bill.
You're moving data around.
Yep. And these aren't just freak accidents. Datanami found like 99% of companies have egress fees planned or unplanned every year. It's about 6% of the monthly bill on average. They called it a huge concern.
Wow, 99%. So egress fees are almost guaranteed.
Yeah.
And okay, these technical mistakes hit the budget hard.
Yeah.
But you're saying the impact goes beyond just the bill, right? poor data quality itself becomes a business problem.
Oh, absolutely. It's not just a tech issue. It leads to things like inaccurate sales projections, maybe lost sales opportunities, even clients leaving because they don't trust your data or reporting.
Can you give an example? Maybe a famous one?
Well, the classic, if extreme example is the NASA Mars Climate Orbiter
I
failure.
remember that.
$125 million lost. And why?
Yeah.
A simple units mismatch. One team used English units, another used metric. It wasn't a hardware failure. It was a data quality failure, a conversion error.
That really drives home how critical basic data quality is,
Yeah.
even for rocket science.
Exactly. And on a, let's say, more terrestrial level, remember Amsterdam's tax office issue?
Vaguely. What happened there?
They ended up with an 188 million blunder because payments were calculated in cents instead of euros.
Ouch.
Yeah. And on top of the massive miscalculation, it cost another $300,000 just to fix the mess. Real money, real consequences from data mistakes.
Okay, so we see the damage. Let's break down why this stuff happens. You mentioned common pitfalls, starting with technical infrastructure blunders. What's top of the list there?
Often it's fragile data pipelines. Teams skip the important stuff, proper CI/CD, integration testing, checking schemas, validating data.
So they rush it.
Yeah, maybe under pressure. And the result is pipelines that just break without warning. Or worse, they keep running but produce garbage data that nobody notices right away.
Which just pollutes everything downstream.
Exactly. Which leads right into the next point, exception handling failures.
Right. So the pipeline produces bad data, or maybe just stops altogether.
Yeah.
How does it usually play out?
Yeah, jobs can just stop, maybe because an API they rely on changed or broke, or there are unexpected null values, or even simple permission issues.
And if there aren't good alerts?
Correct. Without solid alerts or logging, engineers might not even know it happened until, a business user starts saying, hey, this dashboard looks really weird.
And by then, the bad data's already spread.
Yep. Creates a much bigger cleanup job later.
Okay, now this is where it gets really interesting for the wallet.
Mm-hmm.
Costly cloud management. This is the forgotten clusters, the inefficient queries, the over-provisioned compute.
Mm-hmm.
These lead directly to those surprise bills. Give us some concrete examples. How does an inefficient query actually hit the bottom line?
Okay, classic example. Running select distinct on a massive BigQuery table without any filters.
Just selecting everything.
Everything, or maybe ignoring table partitioning. Both force the system to scan potentially petabytes of data. BigQuery charges for data scans, so boom.
Yeah.
Huge cost for one query.
Right. And the forgotten clusters.
Yeah, you spin one up for a quick test, you get pulled onto something else, and you just forget to turn it off. It sits there racking up charges, sometimes for months. It's like leaving the lights on in an empty skyscraper.
I can picture that. And sometimes it's the opposite, right? Not forgetting something, but actually over-engineering it.
Right.
Building something way too complex.
Oh, definitely. Teams get excited about new tech, maybe. They build these intricate systems with message queues, event streaming, multiple microservices.
When something simpler would have worked.
Exactly, when maybe just a simple scheduled script writing to a database table would have solved the actual business problem.
And the hidden cost there is.
Maintenance, complexity, debugging time. You end up spending more time managing the complex infrastructure than getting value from it. It's about using the right tool, not always the shiniest new one.
That makes sense. Finding that balance.
Hmm.
Then there are data modeling problems. You hear about the chaos of unstructured tables or the one big table trap. What do those mean in practice?
Well, the chaos part means tables with no clear relationships, inconsistent naming, just a mess. It makes querying incredibly slow and painful for analysts trying to find insights.
And the one big table trap.
That's where you try to cram everything into one giant table. It might seem simple at first, but as data grows, performance tanks. Queries take forever, cost more, and it limits what kind of analysis you can even do.
Okay. And tied to that is database misuse. Like querying the production database directly for analytics seems like a shortcut, but what's the danger?
Big danger. You can easily overload your main production systems, slowing down the actual business operations. Think checkout carts timing out or internal tools grinding to a halt.
Oof, not good.
And you also risk accidentally exposing sensitive data or even corrupting production data with a bad analytics query. It's just generally a bad idea.
Okay, let's shift gears a bit to process and methodology mistakes. A big one seems to be building solutions that nobody actually uses. How does that happen?
It usually happens when the data team dives into development without really truly understanding the business need first.
So they build something technically cool, but
But it doesn't solve the actual problem the business user had. Or maybe it's too complicated for them to use, so you end up with wasted development time, delayed value delivery, and honestly, a lot of frustration on both sides. Erodes trust.
Yeah, I can see that. Now, security and compliance. Neglecting the basics here sounds terrifying. You mentioned exposing credentials. How fast can that go wrong?
Almost instantly. If you accidentally push, say, AWS keys or database passwords to a public GitHub repo, even for a minute,
Bots will find it.
bots are constantly scanning for exactly that. They can pick it up immediately, spin up massive resources on your account for crypto mining or whatever, and you end up with an astronomical bill before you even know what happened.
That's scary. And beyond just credentials, what about deeper privacy practices, like encryption or access control?
Yeah, storing sensitive user data without proper encryption or giving, like, everyone in the company access to all the data, those are recipes for disaster.
Leads to data breaches, regulatory fine.
Exactly. Things like GDPR or CCPA violations. And beyond the fines, the damage to your company's reputation and user trust can be immense, maybe even harder to recover from.
Definitely. Okay, what about data quality and governance issues? You mentioned ignoring end users. How does that play out?
Well, a data engineer might build a fantastic, highly optimized data model, but if it's confusing or it doesn't match how the business users actually think about the data,
They don't use it.
they won't use it. Or they'll try, get frustrated, and maybe go build their own shadow IT solution, duplicating effort, so adoption is low, frustration is high.
And documentation,
Yeah.
or the lack thereof. Always the first casualty of a tight deadline, right?
Right.
Why is skimping on docs so risky?
Because the knowledge ends up living only in the heads of a few engineers.
The tribal knowledge problem.
Precisely. And when those engineers leave or just move to another project,
Yeah.
suddenly nobody knows how that critical pipeline works or where the logs are or how to update it. Simple changes become massive undertakings. Documenting data flows, pipeline logic, environment configs, it's essential for continuity.
Makes sense. Another one you highlighted was data profiling neglect. Just assuming the input data is clean.
Yeah, big mistake. You build your whole pipeline assuming the data looks a certain way, and then boom, it hits production, encounters some unexpected null value or a weird date format.
And the whole thing falls over.
Exactly. Usually at 2 a.m., you absolutely have to profile your data sources before you start building logic. Understand the shape, the quirks, the potential issues up front. It's like inspecting your ingredients before you cook.
Good analogy.
Yeah.
And then the idea of pushing problems left, analytics right, trying to fix bad data downstream in the transformation layer.
Right. Instead of going back to the source system or an earlier pipeline stage and fixing the quality issue there.
You try to patch it up in your complex SQL or Spark code.
Yeah. And over time, that code becomes this incredibly tangled mess of conditional logic and workarounds. It's hard to maintain, hard to debug, hard to scale. It's almost always better and cheaper in the long run to fix data quality problems as early, as far upstream as possible. Keep the downstream analytics clean.
Got it. Clean data in, clean analytics out. Finally, communication breakdowns. Technical teams may be ignoring feedback from business users.
It happens. Sometimes the tech team gets so focused on the how building the cool tech that they lose sight of the why from the business perspective. They might build something technically impressive, but it's ultimately the wrong thing.
And the flip side, talking too technical to non-technical people.
Yes. Using jargon like schemas, pipelines, distributed systems when talking to marketing or sales, it just causes confusion or makes their eyes glaze over.
So the key is,
Focus on the business value. Translate the technical work into outcomes they care about. Match your level of detail and language to your audience.
right. And lastly, the trap, especially for newer engineers, of saying yes to everything, taking on every single request.
Yeah, it's easy to want to please everyone, but it quickly leads to being completely overwhelmed, burned out, and frankly, the quality of your work suffers because you're spread too thin.
So learning to prioritize is key.
Absolutely. Learning to prioritize, manage expectations, and sometimes saying no, or at least not right now, is crucial for sustainable, high-quality work.
Okay, wow. That's a lot of ways things can go wrong. Now, the important part, let's talk about the how-to. Strategies for actually optimizing costs and improving data quality. Where do we start?
Let's start with smart resource management. Right-sizing and dynamic scaling are absolutely fundamental.
Getting the compute power right.
Exactly. For instance, with Databricks, using job clusters instead of all-purpose clusters for automated jobs is a big saver. Job clusters spin up, run the job, and spin down. Much cheaper than having compute running 2004/7.
Okay, makes sense. What about Azure?
In Azure Data Factory, watch the DW's data warehouse units on copy tasks. The default is often 4, but if you don't need that much power, setting it down to 2 can save money. Same idea with DIUs, data integration units for copy activities. Adjust based on actual need.
And maybe predictive scaling, using past patterns.
Yeah, if your workload is somewhat predictable, you can implement predictive scaling based on historical usage to match capacity more closely to demand.
All right, so compute is one thing. What about the data itself? Storage optimization.
Crucial. You need clear data retention policies. Not all data is equally valuable or needs to be kept forever, right?
Right.
So categorize your data. Think about business value, regulatory requirements, then automate archiving and deletion. Move data that's not accessed often to cheaper storage tiers, like AWS Glacier or Azure Archive Storage.
And there are tools that help automate this.
Definitely. S3 intelligent tiering on AWS is a great example. It automatically moves data between access tiers based on how often it's used. AWS says it saved customers billions. There's also S3 Express One Zone for super frequently accessed data, faster access, lower request costs.
And BigQuery has options too.
Yep. Understanding their logical versus physical storage billing models and picking the right one for your usage pattern can make a difference.
Okay, so manage compute, manage storage. What about the pricing models themselves? Pay-as-you-go, reserved instances.
Understanding those is key. Pay-as-you-go gives you flexibility, great for unpredictable workloads or short projects. Reserved instances, RIAs, offer big discounts, sometimes over 70% if you can commit to using specific resources for 1 or 3 years. Best for stable, predictable workloads.
And spot instances.
Those offer the absolute lowest costs, often up to 90% off pay-as-you-go, but the catch is the cloud provider can reclaim them with little notice. So great for fault-tolerant, non-critical workloads like some batch processing or testing.
So maybe a mix is best.
Often, yeah. A hybrid approach using RIs for your baseline, pay-as-you-go for variability, and spot for interruptible tasks can be very effective.
Makes sense. Moving on to architecture and tooling choices. Serverless is a big buzzword. How does it help with costs?
The main benefit is paying only for execution time. Resources spin up when needed and down when not. This reduces idle time costs dramatically. Think AWS Lambda, Azure Functions, Google Cloud Functions.
And serverless databases.
Right. Things like Amazon Aurora Serverless or Redshift Serverless, they can automatically scale compute up and down based on load, potentially saving a lot, maybe up to 90% in some cases for Aurora, without you managing clusters.
Is that always cheaper?
Correct. For very high throughput, consistently running applications, sometimes provisioned resources with reserved instances might still be more cost-effective than serverless. It really depends on the workload pattern. Analyze your specific needs.
Okay. Another interesting trend is zero ETL integrations. What's that about?
It's about connecting data sources directly to your data warehouse or analytics platform without building complex ETL pipelines in between.
So less data movement, less transformation code.
Exactly. For example, Amazon Redshift can now directly query data in operational databases like Aurora or RDS, or even data lakes in S3. This can drastically cut down development time, maybe from months to days for setting up analysis, and reduces the cost and complexity of maintaining those pipelines.
That sounds powerful. And what about AI and ML? How are they being used for cost management itself?
Several ways. AI can analyze usage patterns and drive smarter auto-scaling, like in Redshift Serverless. It can provide recommendations for cost-saving actions, like identifying idle resources or suggesting better instance types.
And even helping write code.
Yeah, generative AI tools like Amazon Code Whisperer or GitHub Copilot can suggest code, potentially speeding up development. Amazon found Code Whisperer helped their own team's code 25–35% faster. And AI can help author dashboards, like an Amazon QuickSight, or generate SQL queries like Amazon Q in Redshift. Plus, using specialized hardware like AWS Trainium for training ML models or Inferentia for inference can significantly cut the costs of those specific AI workloads. Up to 50% savings on training, potentially.
Interesting. So AI is becoming a cost optimization tool itself. Another point was using purpose-built databases. Why not just use one big database for everything?
Because different databases are optimized for different tasks, and using the right one is usually much more efficient and cost-effective.
Like using the right tool for the job.
Exactly. You wouldn't use a screwdriver to hammer a nail. Use a relational database like Amazon Aurora for transactional workloads. It's performant and cost-effective compared to older commercial options. Use a NoSQL database like DynamoDB for high-scale key-value lookups. Use databases with vector capabilities for GenAI apps.
And avoid using the wrong tool.
Right, like
Oh,
trying to do a massive billion-row transformation using something like Data Factory might be way slower and more expensive than using a distributed processing engine like Spark, which is designed for that scale.
makes sense. And query optimization seems like low-hanging fruit. What are the key takeaways there?
Template your pipelines for consistency. If a pipeline gets too complex, maybe more than 4 or 5 steps, consider refactoring it into a Databricks notebook or similar for better control. Use straight SQL where it makes sense and performs well.
And checking costs before running.
Absolutely critical for platforms like BigQuery. Use the query validator or do a dry run to see how much data it will scan before you hit run. It can save you from accidentally huge bills.
Good tip. Any others?
For large multi-stage queries, consider materializing intermediate results into temporary tables. This can reduce the amount of data scanned in later stages. And definitely avoid select distinct on huge tables without filters. Also, using limit doesn't usually reduce cost in systems like BigQuery if it's not on a cluster table, because it still has to scan the data first.
Right, the scan is the costly part. Okay, shifting from tech to process. You mentioned FinOps discipline. What exactly is that?
FinOps is really a cultural practice. It's about bringing together finance, engineering, and business teams to manage cloud spending more effectively. It involves principles like budgeting, monitoring, and governing cloud costs, specifically for data workloads, too.
So it's about accountability.
Yeah, it's about making sure every dollar spent in the cloud drives real business value and supports the most important initiatives. It's shared ownership of cloud costs.
And a core part of that must be monitoring and alerts.
Definitely, you need that early warning system. Implement regular resource monitoring. Use the cloud providers' tools like cloud billing budgets and alerts in GCP or AWS budgets. Set alerts for specific things like CPU usage spikes or costs exceeding a threshold.
Catch problems small.
Exactly. Leverage tools like the Google Cloud Pricing Calculator or the BigQuery Slot Estimator to plan costs upfront, too.
And communication again. We talked about the breakdowns, but how do you fix it? Prioritization.
Yes. Bring stakeholders in early. Really understand the business need before you start building. Validate the requirements. Then practice rigorous prioritization. You can't do everything at once.
Learn to say no.
Or not right now. It's essential to manage expectations and avoid burnout. And again, tailor your communication. Talk business value with business folks, technical details with technical peers.
Right. Finally, let's talk data quality management in more detail. What are the key steps?
First, implement actual data validation and cleansing. Use automated tools where possible, maybe some manual review for critical data. Focus on standardizing formats, removing duplicates, maybe enriching data by adding missing pieces.
Get the data accurate up front.
Then establish data governance. Define who's responsible for what: data stewards, custodians, owners. Set clear policies for how data should be accessed, stored, and used.
Create accountability.
Exactly. And create data quality metrics. Track things like completeness, accuracy, consistency, timeliness. How else do you know if you're improving?
Measure to manage it.
Right. And it needs to be continuous. Ongoing monitoring and assessments with corrective actions when issues are found, always profile new data sources, and, crucially, push fixes upstream whenever possible. Fix the problem at the source, don't just patch it downstream. Keep those analytics pipelines clean.
That seems like a much more sustainable approach.
Yeah.
Okay, we have covered a ton of ground today.
We really have.
We've seen how these, seemingly small mistakes, a forgotten cluster, a bad query, poor communication can snowball into absolutely colossal cloud bills and major operational headaches. We're talking tens of thousands, even millions in some of those stories.
Yeah, the potential costs are staggering. But the flip side is we've also unpacked some really powerful strategies. Things like FinOps, using serverless effectively, smart storage tiering, meticulous data governance, even leveraging AI.
Right, these aren't just about cutting costs, are they?
Not at all. They're about transforming those challenges into real savings, yes, but also into better data quality, more efficiency, fundamentally building a more robust and intelligent data foundation.
So this deep dive really shows you, the listener, that managing cloud costs in data engineering isn't just some boring accounting exercise. It's actually strategic. It's about building that solid foundation that lets you innovate and drive business value, but without those nasty financial surprises popping up.
Well put. It enables sustainable growth.
Okay, so as we wrap up, let's leave our listeners with a provocative thought to mull over.
All right, consider this. Data volumes are exploding, right? Estimates suggest we'll hit 175 zettabytes globally by 2025. Annual data growth is averaging around 30%.
Just staggering numbers.
Insane numbers. So, Given that relentless growth, what's the next frontier in cost optimization beyond the strategies we've talked about today?
Good question. How are organizations going to balance this insatiable demand for more data, more insights, especially with AI driving even more data usage?
With the absolute imperative to control those rapidly mounting infrastructure costs, what comes after serverless, FinOps, and AI-driven optimization as we know them now?
That's definitely something to think about. How do we keep up without breaking the bank in this data-driven future?